Hello there, I will guide you through our project of the course of Discrete Mathematics, which covers the closest pair of points algorithm. Now, let's look at the problem statement. Given n points on the plane, each point is defined by its coordinates xi, yi. It is required to find 2 points such that the distance between them is minimal. Now, let's look at how we approach the problem in different ways. First of all, we can use the brute force method to solve the problem, in which we can select each point and find the distance of the point from each point present in the plane. But that would give us a running time of big O of n square. That's not practical to use in real world scenarios. There is also another method of divide and conquer algorithm, which is similar to the merge sorting algorithm, in which we first divide a problem into 2 or more subparts and solve it, and then we merge the solution of subparts to obtain the original problem solution. Let's have a look at an example that will explain the algorithm, which takes big O of n log n running time. First of all, let us look at the base cases. There is only one point in the plane, then there are no pair possible, so no minimum distance will be found. If there are 2 points, then the distance between them will be the minimum distance. And if there are 3 points, then we will calculate the distances pairwise and return the minimum distance. There is a plane with 16 points. Let's find the closest pair of points in the given plane. Divide the plane until there are 3 or fewer points on the side of the divided part. We will find the distance between these points with the brute force technique. Delta r is the minimum distance found on the right part, and delta l is the minimum distance found on the left part, and delta is minimum of these two distances. Now, after we are done with minimum distance on the left side of the partition and the right side of the partition, we should see if there is a pair with 1 point on the left and 1 point on the right side of the partition. If such points are found and the distance between them is lesser than delta, then we will return that distance. Now, we'll merge the section which has points 1, 2, 3 and 4. As we have calculated the closest pair of points on the left side of the main left partition, we will do the same process with the right side of the main left partition. That part is highlighted with grey color. As there were 4 points in this section, we will divide it again, and now there are 2 points on each side, and we will do the same process till we find the closest pair of points. Now we will find the closest pair on the left side of the plane and the right side of the plane. Then we will merge this part as shown before with the right part of the main left partition. Now we have the closest pair on the left part and the right part of the main left partition. After merging them as the same procedure followed before, we will get the closest pair of points on the left partition. Following the same method, we will find the closest pair of points on the right partition of the plane. Now, we have the closest distance between the pair of points on the left and the right side of the partition. Now, we will check if any such pair exists, that its 1 point is on the left side and 1 point on the right side of the partition. Now, we will make a strip of width 2 delta and height delta. We can show that this takes constant time as there are 8 max points to compare in this rectangle. So every time we combine or say merge the subarrays, we will check by using this strip, as there can be points with minimum distance with points being on different side of the partition. If there is a pair of points found in strip such that the distance between them is lesser than delta, we will return it, and that will be the final answer for the minimum distance between 2 points in a plane. Finally, we now have the closest pair of points in the given plane. Now let's see how can we commercialize our project. The closest pair of points problem arises frequently in many domains. Anytime you want to know the closest 2 objects in a group, this algorithm can be used. Such objects could correspond to stars in a galaxy. Nowadays, on an average, there are 176,000 commercial flights per day. Because of the increased popularity and efficient transporting facility, the air traffic is increasing day by day. So for controlling air traffic, for instance, it would be useful to know which 2 planes are closest to one another in order to prevent a collision. Other real-world application includes geographic information systems and molecular modeling. Thank you for your time. We would like to thank Professor Rahul Muthu and Professor Manish Gupta for giving us this opportunity.